like I work with, they were doing phenomenally. They were getting way above 90s and 100s on the tests. And it seemed to me as if he was making the tests easier toward the end of the year. Now, maybe he got pushback, and maybe his test will be different this year. So let's just hope, okay? Let's just hope.
Yeah.
So in this problem, we have 25 to the f. Now, last year, you never did. Did you ever do fractional exponents last year? I don't remember.
No, but like these are like easy though. Just 5, just the square root of 25. But
Right?
like when it gets to stuff like this, like that's like when I have like trouble.
Like which one? Show me, please.
Like D, C.
Yes. Yes, you have a problem there.
Yeah.
Okay.
It's not that I don't know how to do the math, it's that I forget the rules like while I'm doing it. And like I add the exponents or multiply them when I should add or should multiply.
Right. Yeah, so basically you not this what this is just the exponent rules. So the exponent rules x to the a times x to the b is x to the a plus b. And this is a very important one. X to the a to the bth power is x to the a times b.
B.
Right?
Yeah.
Right. So what you have to do with the exponent rules is you apply them just blindly, and you got to trust them. It's a psychological thing. They always work, and a and b can be anything, literally anything. A and b can be fractions. A and b can be negative numbers. A and b can be anything, like x to the negative 7 divided by x to the negative 9 is x to the negative 7 minus a minus 9. See, because when you divide them, you subtract the exponents, right?
Yeah.
Yeah. So you just blindly follow it. You just blindly follow it. And when it becomes really crazy, it's the same stuff. Like x to the negative 5 over 7 divided by x to the negative 0.3 is just x to the negative 5/7 minus a minus 0.3. You just blindly follow the rules and you get the answer. So should we go to that one that was giving you trouble?
Yeah.
Okay.
Like I spent like 20 minutes on this one.
Did you eventually get it?
Yeah. Usually like it like takes a while for me to just like understand what the problem's asking me. And once I understand that, I get it. But just like
Right. Now this is tricky. This is tricky because uh, you have that 8 there, right?
well for the 8, what you would do 2 to the third. You would make it 2 to the third,
Right.
2 to the third, parentheses, and 3 to
Squared.
3.
Squared. No, no, no. 2 to the third. It's 2 to the third squared. So you got 8
Yeah.
is 2 to the third squared.
2 to the third. Yeah, squared. Draw. 2 to the third squared.
So it's 2 to the
Yeah,
6th
yeah, 2 to the 6th. Yeah.
times 5
Times 5 to
cubed. But this is all 2 to the 3 over 5th power. So that's 2 to the 6 times 3 over 5
yeah, to
times
this
5, 3 times 3 over 5.
yeah.
And this is divided by 2 to the 3 over 5 times 5 divided by 1/5.
Yeah.
And then you just blindly use the exponent rules. The top one is 18 over 5, and the other one is 9 over 5, right?
Yeah.
And then you just do exactly what you do, and then you're subtracting them. So it's 2 to the 18 over 5 minus 3 over 5 times 5 to the 9 over 5 minus a fifth. So it's plus a fifth.
Wait, where did you get? So you had 2 to the 18th over 5 times.
No, I'm
Oh,
doing the twos first. I'm doing the twos first.
oh, oh. Then you subtract top minus
Right,
bottom.
I'm subtracting. I'm blindly following the exponent rules but just totally trusting them. See?
Okay.
And then you deal with the fives. First you deal with the twos, and then you deal with the fives. You see,
Yeah,
5 and 9 fifths, and then it's a minus a fifth, so it's plus one.
like that's a mistake. Like instead of subtracting, I would like do like multiply the exponents on top, or add them all together.
Oh yeah, no, you can't. You mean you were combining somehow the 2 and the 5. You were combining the 18,
Yeah,
5, and the 9. No, no, no. You're only allowed to do that when you have what's called the common base, right? You're dealing with
yeah,
a 2 or
but
a
don't we
5.
have the same common base as 5 and 18 over 5? But that's not a base though.
Right. It's not a base. That's an exponent. Right. Yeah. It takes some experience. It takes some practice.
Like this is the first time I've ever seen anything like this. First day.
Yes. Well, yeah. I know. This is well, remember no. Do you remember 2 years ago? You had that insane, remember the first test of that crazy class you were in 2 years ago where it took us 6 hours to do the review sheet? Remember that weird
Oh
stuff?
yeah, I did well on the test. I remember that.
Yeah. By the way, I think those were fractional exponents. Weren't those 2 years ago? You were dealing with a lot of radicals. Remember that? Remember that sheet that was crazy? Or no, it was common factor. It was greatest common factor, least
Yeah, it
common
was like
multiple.
it was like factoring.
Yeah. It was really, really weird. So you've seen really hard stuff at the beginning of the year. But yes, I sympathize with you. This is nasty stuff. Yeah, yeah, yeah.
So like
This is. By the way, this is not ninth grade math, which is what you're supposed to be in. This is 11th grade math. Okay, this is algebra 2 stuff. So.
but don't you take geometry in ninth or no?
No, yeah. No, in New York State, you take Algebra 1 in ninth grade, Geometry in 10th, and then Algebra 2 in 11th, but you're advanced. So you're taking Algebra in 8th grade, and you're going to take Geometry in ninth grade, and you're 1 year
Uh,
ahead. But this is supposed to be a classic algebra class, but it's not. It's way above the ninth. It's way above the state level. Way above the state level. So. It's not your imagination that the stuff is hard, but with the exponent rules, you just keep absolutely straight what you're doing, and you just follow the rules, and then you get through the problem. And you are very right. If you see an 8, you have to change it to a 2 cubed, to the second power, which is then 2 to the 6th. So.
yeah.
And we're not on Zeitboard, so if you want to keep this, you should make a screen print. Because once we
There.
do the clear, it's gone forever, as opposed to Zeitboard where you can go back to it.
I just take a picture on my phone.
Yeah,
I don't know how to
absolutely,
take
absolutely.
a screenshot on my
Yeah.
computer.
I mean, sometimes we will use Zeitboard, but most of the year we're going to be on here because we're going to be working directly on your screen.
Yeah, I took a picture.
Now, Dan gives the answers pretty fast, if I remember correctly. Like within a day or two, he's going to flip the switch and you'll be able to show the
No,
solution.
this is my homework from tonight.
Oh, good. Oh, yeah, okay. Yeah, yeah.
So yeah, I can see if I get it right or wrong, but like
Oh, good. Okay, and can I clear this?
yeah.
Yeah, right. Okay, good. But I think his computer recognizes how many times you have to try it before you get the answer. So I think last year, like he was able to tell.
No, like what he told us this year, because we don't put our actual answer in here, we put it in our notebook. And like what he told us is just put like a random number, a letter, and just click show the solution so you can see the answer.
Got it. Okay, good. Okay.
All right, so on C,
Yep.
um, would I do power to power with 1/2 and three halves?
Wow. Well, the 12. You know what I would do?
Oh, would you make it 2 squared times 3?
Yeah. Yeah, I would do 2 squared, which is 4, times 3.
Parentheses.
Oh, this is to the 1/2 power, right?
Yeah.
And then this is to the 3/2 power,
Yeah.
right? So then it's 2 squared times, whoops, 2 squared times 3 to the 3/4 power, right? Because it's 3/2 times a half, right?
And then it would be it would be you would raise the two you would raise the exponent from the 2 to the 3/4, right?
That's right, and then it's 2 times
And it's
3/4 times 3 to the 3.
and it's 3/2, right?
That's right, that's right, that's right. So it's 2 to the 3/2. You do it very slowly. 3 to the 3/4. And now you bring in the other junk. Times 3 to a
So
quarter times 2 to a half. Right. And now you use the product rule.
can I make the 2 to the half 2 to the 4th? Yeah.
What's that?
Should I make like 2 to like the exponent on 1/2 2/4? It's the same thing, or no? I don't know. Never mind.
No, I mean, you could, but then you're going to have to simplify later.
I don't know.
So now this 3 to the 3/4 and 3 to the quarter means 3 to the 1
One,
because
yeah.
you add, right?
3 to the 1. So
And then that's 2 to the half plus 3/2 is squared, right?
yeah. So it's 2 squared. So it's 4. 4 times. It's 12.
So let's see if 12 is the answer.
Um, yeah.
All right, there we go. Now notice there are different ways to do it, right? The way they did it may have been slightly different than the way we did it.
Wait. Let me check my notebook. There's one that I wasn't able to do.
Okay, yeah, let's go over it.
1.73.
I'm going to clear that. Okay. Which one is it?
But I'm looking. Um, on B, I was just confused, like what to like do.
B?
Yeah, because of like the 1.
Okay. Well, okay, what does x to the a divided by b really mean? It is the bth root of x to the all raised to the 8th power, or it's the bth root of x to the 8th power. Either one works. Either one works. Either one works.
Like, so how I started solving this problem was isolating the negative sign,
Okay.
just putting it at the end. So just 1 to the power of 36 over 5. So is the answer just negative 36 over 5?
No, 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 no. No, 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 no. So wait, so what you did is did you do this? Did you say -1
Parentheses.
times 1, and this is to the 36 over 5? Well, that's actually the same. Wait,
Yeah.
wait, what did you do? What did you do?
Usually when I see a negative sign, I just isolate it. You just put it in at the end.
No, no, what you got it? Well, the better thing to do here is,
I mean, that's what he told us to do.
wait, I'm sorry, what did he say?
Like when you like if I see this like negative like -7, make it -1 times 7.
Yes, that's a good idea. But then if you have -a to the bth power, you make it as -1 to the bth power. Okay. Let's go over it in a logical way. Ready? Negative -1, -a to the bth power, right? um, negative a to the bth power is negative 1 times a all to the bth power, right? See that?
Mhm.
Right? So that is negative 1 to the bth power times a to the bth power. See that?
Yeah.
So that's what he's saying to do. He pull out the negative 1, but the negative 1 has to be raised to the bth power.
So is the answer -1?
The answer here is negative 1, because what you're doing here is you're looking
Just
for the,
cancel. It cancels each other out. No.
wait, no, it's not negative 1. Wait, hold on. No, it's not negative 1. No,
Yeah.
wait, it's positive 1. It's positive 1.
Because negative times negative. No. What?
It's positive. Okay, wait. Negative, you take the fifth root. You take the fifth root of negative 1.
But we
Okay,
also don't. We also don't have calculators.
the what?
We don't have calculators.
I know. Well, the fifth root of negative 1 is negative 1. Okay?
Yeah.
Because you can multiply negative 1 5 times, you get negative 1, right?
Mhm.
But that's raised to an even power. That's raised to the 36th power.
Oh yeah. So it becomes
So it's
positive.
positive 1. It's positive 1.
Oh yeah. That was another question when I was doing this problem.
Sure.
Like when I see the power even or odd, which like one do I do? 36 or 5? That
It's not a power. The 5 doesn't mean a
the 5
power.
is
The 5 means the
divided.
fifth root. The 5 means the fifth root.
Yeah. That's how I was confused.
So an odd root.
So the 36 is the power, and then the 5 is just dividing the 36.
No. No. The 5. No. The 5 doesn't. The 5
Doesn't
doesn't
have,
divide the
no,
36.
but like no, not that's not what I'm gonna say. But like the 36 is the power, and like when you if it's even, like that's what you look at when it's even or odd.
Yeah, I mean, see, the thing is, there are two ways to look at this. You could take negative 1 and raise it to the 36th power. What is negative 1 to the 36th power? It's positive 1, right?
Yeah. No.
Now, take the fifth root of positive 1. The fifth root of positive 1 is 1.
Yeah. Okay. Oh yeah.
Or you could take the fifth root of negative 1, which is negative 1, and then do negative 1 to the 36th power, which is 1. Do you see how you could view it both? You could view it one of two. You could view it two different ways. Um, the, the,
So the second number is the whatever root to the thing you get with with the base and the exponent with the number.
right, exactly. I'm going to clear this for a second to make it more clear, and I'm going to make it bolder. Okay, x to the a divided by b is equal to the bth root of x, all raised to the 8th power, or the bth root of x, and then you raise it first to the 8th power. Do you see? See
Yeah.
that? You
Yeah.
may want to write that. If that's not clear, if that's not completely, like in your notes, you should write that down. Because this is
Okay.
absolutely basic.
He also, the first thing he said to us was not to take notes.
Okay, well that's completely ridiculous. Okay, that is
No,
completely,
he goes too fast to take notes. It's like actually true.
well, tell you something. In about a week and a half, you are going to have a copy of this book, and you can take as many notes in your book as you want. Okay, because you're going to own this book. Okay, it's going to be yours. See?
Yeah.
This book. So you'll be able to take as many notes as you want in your own textbook, and it'll be really helpful to have a hard copy of this
Try to bring that to class.
thing. Oh God, I would not bring it to class. I would leave it at home
Okay.
because you're going to want to take the notes. It's not going to. I mean, how do you do this in class? Do you sit on a computer in class and do this?
No, he like makes a slideshow and he picks the stuff that he wants to do off the slideshow. And it's like he's like the first thing he says to us is like in this lesson, he like showed us how to do just how to do 25 to the half power. That's everyone knew how to do that from the start.
Right.
So he wasn't teaching us anything there. And then like 5 minutes later, he was like, yeah, do this.
Right, you see, but it's the same application. And by the way, you have that negative sign. Do you see what I did? Hey, look, you see what I did? See that? See that? I pulled the negative one out, and then that's exactly what I did, right? You pull the negative one out, and then you distribute it. Then you do negative one like that. That's it. The negative sign, of course, means that it goes downstairs, right? X to the
Yeah.
negative a means 1 over x to the a. These things, these exponent rules can get very, very intimidating, but if you literally just apply them one step at a time and piece them out, they're doable. But he doesn't want you to take notes during school.
Yeah.
That's really insane. That is, how do you expect to learn any? How do you expect to carry it home?
He's like, he was like, yeah, it's on the textbook here if you have a question.
Well, where in it's the textbook? Does the textbook see what I have in green? Does the textbook? The textbook's got to have that explicitly there, right? It's got to. Does it?
No, we never learned the square root thing. I think we do it differently.
Okay. Well, okay. Does this help when you write x to the a over b is the bth root of x raised to the a power, or the? Does this help?
Yeah.
Okay. This is absolutely fundamental. This is one of the beefs I have with this book, is that they're so into the fancy stuff that they don't do the actual basic stuff that really helps you understand what's going on. They go all of a sudden they go crazy with these crazy questions, but they don't quite really make it clear what the basic stuff is. It's really strange. I mean, here it is, right? Here this is it, right? That's what I
Yeah.
just wrote. So,
Yeah. Yeah.
yeah. Really, they don't explicitly have this here, do they? Wow.
And
Clean.
then he also doesn't like explicitly tell it to us. He just reads it. He's like, so you see this?
Oh God. Okay. Uh, Wait. This is introduction to algebra. Follow the rules. What chapter is this again?
1.7, I think. Yeah.
Oh, 1.7. 1.7, the algebra rules. 1.7, the fractional exponents. Wow. So nowhere do they actually give you the exponent rules, even in the summary, because sometimes they have a summary at the end. Oh, the radicals. You see 1.8. If you go ahead to 1.8, then you're showing radicals.
Yeah, we haven't learned that yet.
Oh, God. Yeah, I remember last year. There it is, there it is, there it is. Problem 1.37. Oh, you can't jump ahead to 1.8, can you?
No, I can, but like,
Okay, well, I don't know if you could see my screen.
here, where is it? 1.37?
Problem 1.37.
Yeah, here.
Oh, but you don't have the text.
Here.
No, go a little bit lower, go a little bit lower, go a little bit. Oh, there it is. Wait, there it is. Wait, go up, go up. There it is. There, stop. Go up. Okay, stop. There it is.
N is a positive
See?
issue
See that?
and greater than 2 then.
See that? It's important. Hello? Yeah, it's important. That's what I just wrote, right?
Yeah.
Oh, I see. But they didn't do it yet because they didn't do the radical sign.
Yeah.
So I assume the radical sign, but that's the key. That's the key. That's the key. So what they did is they talked about the nth root in the previous section, but they didn't write it this way. So it's
Okay,
a little bit.
we
What?
did this last year, 1.38. We did that.
Yeah.
That's
Yeah.
the cube root of 625.
Yeah, this gets a little tricky. You got to convert everything to common root, right? Which looks like 5. Wait, what is that? The cube root of negative 135?
I'll look at it. I'll do. I'm gonna do it tomorrow. So
Yeah. Right. So is there anything else on the section that you did that you want to go over?
let me look. Show up. I just need like practice doing it. Can we do this one?
Sure.
1.31.
So, yeah, so why don't, where is it?
At the bottom. The answer is here. I don't want to see the answer.
Right. Yeah. Right. Yeah, there it is. Good. So, let's do the negative sign first, okay? It's negative 1 to the negative 2/3. So let's just do that, okay?
Yeah.
So, okay, negative 1 to the negative 2/3. The answer is either 1 or negative 1. So what is that? What is negative 1 to the negative 2/3? Is it 1 or is it negative 1?
-1 to the -2/3.
Right. It's either going to be 1 or negative 1. Which one?
1.
Yeah, it looks like it would be 1 because when you square the negative 1, you get 1, and the negative sign brings it downstairs. So the answer is
negative times a negative is positive.
right, because you're squaring the negative 1.
Yeah.
So that means it's positive 1. Okay, great. Now let's do 216 divided by 125 to the negative 2/3. So what is that negative sign? What does the negative sign in the exponent do first?
Is squaring by a negative number.
No. The negative sign. This negative sign. What is that? What is that an instruction to do, this negative sign?
Flip it.
Right, exactly. So let's do that. Because nobody likes negative exponents. Negative exponents are disgusting. We get rid of them as fast as we can. So now we have this problem. You see how we're doing one thing at a time? Now we have 125 divided by 216 to the 2/3 power.
But wouldn't we do three halves or no?
Oh, wait. No, wait, I flipped them. No, I flipped them. I put the 125 upstairs and I put the 216 downstairs.
You don't flip both of them.
No.
They don't do the same thing.
What?
If you flipped both things, it would be the same thing that you had to start.
No, it's not. It's not. Because here you're taking the cube root of these guys. Cube root.
Oh.
If you flip them, then you're going to be taking the square root of them. It's completely different. It's no. The negative sign is not a negative number. The negative sign never makes anything negative. What it does is an instruction to flip. I've been lucky enough to be in your house where I know you have an upstairs and a downstairs. The negative sign means that your mom says, hey, get downstairs.
Like when you see a negative exponent, just take the reciprocal of the base or this thing.
I'm sorry.
I don't know if
what do you think?
Like if you see a negative exponent, just means do the reciprocal of this.
Absolutely. The negative exponent is an instruction to flip. Nothing more than that. Nothing more than that. So if you have 1 over 7 to the negative 4, it's really 7 to the 4. Right? Because the negative sign is an instruction to flip the base. Right. That's right. Okay?
Yeah, I got it.
So generally it's a good idea. In this case, it's absolutely the better thing to do is get that negative sign out of there by flipping the base. Now you're stuck. Now you have to do 1/25 to the 2/3 and 216 to the 2/3. So this is 125 to the 2/3, and this is 216 to the 2/3. Okay.
Then I could just make. Then I could just make it 5 squared to the 2/3 over 6 squared to the 2/3.
No. You've already the third by having 125 to the 2/3. It's saying, give me the cube root of 125 and then square it. See, when you did the 5, when you said 5, you got it by taking. I hope you got it by taking the cube root of 125. Is that?
Yeah.
Right. So once you do that, you don't say to the 2/3 anymore. You don't do 5 to the 2/3. You've already used up your third. right?
Yeah, I know. I was talking about the bottom though.
Yeah, the bottom one is saying the cube root of 216,
It's 6.
and now you square. Now don't say cube root anymore. Don't say third anymore. You've used it up. Now you squared.
Oh, you see, so yeah, you do the root. Here you would just do the cube root of both of them and just add the exponent.
No, I wouldn't do both of them. I would do one at a time.
But you do,
125. The cube root of 125 is 5. Then you square it. You get that. Cube root of 216 is 6. So then you square it and you get that.
but for like when it's division or a fraction like this, a number over a number with a fractional exponent, you do the you do the whatever root it wants times, and then you add the exponent after you do that.
Okay, the fact that they're fractions should have nothing to do with it. What I would do here is ignore this. Just totally ignore this. Just completely take this out of your head. Because the bases aren't the same, you see? There's no common base between 125 and 216. These have nothing to do with each other. First you do this one. You put your pinky, you cover it up. First you do that, okay?
Okay.
And after you do that one, then you cover this one up, and then you do that one. Okay? They're not common bases, so you can't combine them. They're totally separate problems.
Okay. Okay.
I mean, can I erase this?
Yeah.
Or, you absolutely do have problems like this, though. You could easily have, I don't know, here, 100 divided by 25 squared. Okay? So here you're welcome. You really are welcome to do 4 squared. Okay?
Yeah. That's
Right?
it.
Well,
Yeah.
no, let's do square root. Sorry. You're welcome. I mean, in a weird situation like this, if you want to take the square root, right, you can do 4 square root, which is 2, or you can take 10 divided by 5, which is 2. See, you can take the square root of 100 and the square root of 25, which is 10 divided by 5 and get 2, or you just do the 100 divided by 25, which is 4, and then take the square root and get 2. But only when you really can simplify the fraction. But if you can't simplify 125 over 216, there's no way to simplify.
Yeah.
Yeah, Serena, what other ones were giving you trouble with this unit, with this stuff?
I love. Didn't give me trouble. Just is there's not a faster way to do it than factoring everything out using a factor tree, right? Getting the prime factors.
Which problem is that?
D.
Oh, yeah. The problem there is when you go into radicals, the next section, yeah, it's going to be more of a problem because you're going to remember if we jumped ahead, you're going to be doing the square root of weird stuff like 40, which is going to be the cube root, which is the cube root of 8 times the cube root of 5,
Like
right?
how I solved that problem was I did this. I don't know if you can see it like this.
Yep, factor tree, right?
Yeah.
Factor tree is the way to go. Absolutely right. A factor tree is the way to go. Absolutely, of course. Yeah.
And then after you do that, it's easy. But
Yeah, factor tree is definitely the way to go. Of course.
then check. Or 1.7.4 A and B are different, right?
Uh, is there a positive or negative number that equals 4 to the 1/4? Well, they're asking, they're asking for the 4th root of 4. So, yeah, I mean, there seems to be a positive number that's true. Now, is there a positive or negative number? They're asking you for the 4th root of -4, right?
Yeah.
So is there a number that you can multiply 4 times
To get a negative number, no.
And that's right, it's impossible. That's right. So the answer is no.
Yeah, that's what I thought.
Yeah, yeah.
Um, no, that's like all the questions are kind of the same.
Yeah, these are all the exponent rules, and you just have to stay calm with them. If you're lucky enough to have a common base, then you can use the exponent rules. If you don't have a common base, you better try to force a common base.
Yeah, they
Like when
got
you
a. There's a rumor that there's a pop quiz tomorrow. So
what's that?
there's a rumor that there's a pop quiz tomorrow.
Oh, okay. Does it? Okay. I mean, it's good we met then. It's good we went over the stuff. Um, Again, hopefully this means something to you, even though we haven't done radicals. But you know you know what radicals are.
Yeah.
It just means the root, the bth root of x raised to the 8th power. And
Yeah.
usually it makes sense to do the bth root first. If you looked at all the stuff we did, like here you did 125 to the 2/3. You'd be crazy. You'd be insane to do 125 squared and then try to find the cube root of 125 squared. I mean, that would be really
So
stupid.
so assuming there's a pop quiz tomorrow on C, if I were to write um uh the third root of negative 216 to the first power would be right?
The third root of negative 216 to the first power would be correct, right? Exactly. You want to get the cube root of negative 216, right?
Why didn't we just do radicals before this? It'd be so much easier.
Why what?
You should have just done
Yeah,
radicals.
and the radical is a cleaner way to describe it. But if you look above, they said the third root of, but the cleaner way to write it is use the radical sign. Of course it is.
Okay.
It's very obtuse to say the third root. It's easier. Your brain already knows how to process this,
Yeah.
right? But maybe they came from the point of view that maybe they're coming from the point of view of people who've never seen the radical sign before, which is ridiculous. So
Okay.
yeah.
Yeah, I don't really have any more questions. They're kind of like the same problems. All of them.
Yes, they are the same, and then looks like the radical stuff's going to get a little trickier when with the common base. Um, but it's good that you are given the answers. Um, but yeah, you have to play common base. Um, and the simplifying radicals, I think you have done before.
Yeah.
Um, yeah, yep, yep. Okay. Okay, so, we're going to meet, unlike last year where we only met before the test, I think we're going to meet once a week, absolutely once a week this year,
Yeah. Yeah. This year's gonna be much more challenging.
to say the least. This year is going to be very challenging. But we don't know what his tests are like, right? We don't know whether he's going to start out doing what he did last year or he's going to do what he did at the end of the year where the tests were more reasonable. So we'll
Yeah.
see.
And like the tests are also 8 questions, like 8 to 10 questions. He said
Right, right.
he's one of those people.
Now, toward the end, I started catching on to this thing sort of like around last December, and I bought all these competition books, and I made these review books because I know I worked with Margot last year, which I'm sure you know. I'm not giving a big secret away. Um, so I have all these review questions that I can give to you to help you study for the tests.
Yeah.
So, yeah.
Good.
Plus, the book has review questions, and then you have these challenge questions, which apparently you do as a class together before the test. So.
Okay.
Yeah. So, yeah. Okay. So I guess
Okay.
I'll see you, well, next Tuesday. I think we're scheduled to meet next Tuesday, but I hate to shudder to think if anything comes up, try to contact me during the week, and I can't promise you I'd get back to you immediately, but I can try to get back to you as soon as possible.
Okay. Thank you.
Okay? And if things get really crazy, I am around. You don't have school Friday, and I'm around. If you have any questions, we could talk for a few minutes on Friday if you want.
Okay. Thank you.
Okay, good luck. This is going to be a rough year, so get ready. Hopefully it won't be as crazy as last year. Hopefully the teacher calmed down a little on the tests, but you will get through it. You will get through it, but you will get through it. You will get through it. But
Yeah.
okay. Okay. But anyway, we're here to help you, so you'll get through it.
Thank you.
Okay, hang in there. Hang in there. Okay, speak to you later. Take care. Thanks. Bye-bye.
Hey, Joel.
Oh, hey, Jack. How you doing?
I'm good. How are you?
Good, good, good. It turns out I have about, like, I'm gonna, they're gonna work, I have to work with someone at 10 o'clock. So I have just a few minutes. So, we'll have to have the pleasantries later about how our summers were, but what's going on? What do you need help in?
Okay, so basically, I had some homework, and there were 4 word problems, and there were a couple regular problems, and I was having some trouble with the word problems. It's, inequalities.
Yes, what page? I have the textbook. What page?
Okay, so the thing is, she gave it to us as a like a worksheet, like a paper for this one. So should I just send over the?
Yeah, yes, that'll be great.
Okay, cool. Okay, let me just take a picture.
Okay. Is this due tomorrow?
Yeah.
Oh boy. Okay.
Coming through now.
Okay, so which one is this? Which
This
problem?
is the word problem.
Right, which one?
Wait.
I mean, which one do you want to go over? Which one?
Oh, can you check over the first one? And
No, the trouble is I have to meet with someone at 10. So I literally only have 12 minutes.
Okay, so do you think it's possible to do 2, 3, and 4? Because those are the ones I had the most trouble with. Like I couldn't.
Okay, let me see. The 3 sides of an equilateral triangle increase by 20, 30, and 40 centimeters respectively. The perimeter of the resulting triangle is between twice and 3 times the perimeter of the original triangle. Oh my god. What can you, oh my god. Yeah, I mean, the 3 sides of an equilateral triangle increase by 20, by 30, and by 40. The perimeter of the okay, twice. Okay, the perimeter of the original triangle. The perimeter of the perimeter of the original triangle is 90, isn't it?
No, I thought it was 3x. Right?
Oh, yeah. Right, yeah, the perimeter's, that's right. Wow. The perimeter of the resulting triangle, the original triangle is 3x, so it's 3x. Yeah, it looks good. Yeah, it looks good. It looks like you set it up correctly.
Yeah, but the thing is, it just gets so confusing. Like, it becomes 6x is less than 3x plus 90.
Yeah.
Which is 9x.
Yeah, you have to split it into 2. You have to split it into 2 inequalities.
Oh.
You split it into 2 inequalities. You say 6x is less than 3x plus 90, and then 3x plus 90 is less than 9x, and you solve the 2 inequalities separately.
Okay.
And it's an AND inequality. So yeah, so that's how you do that. The telephone company offers 2 types of service. With Plan A, you can make an unlimited number of calls per month for $18.50. With Plan B, you pay $6.50 plus 10 cents a minute for each call. Right. Oh wait, plus 10 cents for each minute of calls after the first 40 minutes. Oh my god. Oh my god. Wait. My god. How many minutes would you have to use the vocabulary each month to make Plan A? So this could be an equality. In this one, you just set the 2 equal and solve for it. Right? Plan A, you have to But plan A, you make an unlimited number. For plan A, you can make an unlimited number of local calls for 1850. So that means it's just 1850, right?
Right. Per
The
month.
other one per month, yeah. In plan B, you pay $6.50 plus 10 cents for each minute of calls after the first 40 minutes. Damn, so it's an offset. So it's, oh my god. So it's $6.50 a month plus 10 cents per minute of calls. Well, okay, for the first 40 minutes, let's say you make 40 minutes of calls, right? If you make 40 minutes, if you just do 40 minutes of call, then it's $6.50, right?
Right.
So plan A is never better, right? So before the first 40 minutes, plan A sucks, right?
Yeah.
So forget the 40 minutes, right? So then you want to go above 40. So then it's just $6.50 plus 10x.
Is
And then
what?
is so 6.50.
Is less than or equal to?
No. You just forget the less than equal. You just do the equal. 1850 has to equal 6.50 plus 10x.
No, it has to be less than because it says.
Yeah. So it's less than, right? Exactly. So it's 8. No. It's the other one. It's 650 plus 10x has to be less than 1850. Oh no. Wait. Yes. 1850. That's right. 1850 has to be less than 650 plus 10x. That's right. 1850 has to be less than 650 plus 10x.
X is the amount of minutes over 40. Right?
Exactly. So whatever x is, you got to add 40 to it. Okay. And don't solve it because we have to move on to the next one.
Okay.
Okay. So that's what it is. It's 1850 is less than or equal to 650 plus 10x. Whatever x is, you have to add 40 to it.
Why 40?
Because 40 minutes are free. 40 minutes. Because you first have to use. You get 40 minutes for free with Plan B.
Okay.
Right.
X is greater than like whatever it is plus 40.
Yeah, x is what the answer is. X is whatever that equal that so that equation is plus 40, because you have to add the 40 minutes back in.
No, you're not getting charged for the 40 minutes.
I know, but you're spending the 40. In order to get charged only 10 cents a minute, you have to first spend 40 minutes. You first have to talk for 40 minutes before the 10 cents kick in.
So okay. So if I solve it, so 6 over 5 plus 40 is less than x. Does that make sense? Right? Like.
What? It's 1850 is less than or equal to 650 plus 10x.
Less than or equal. Okay.
Plus 10x, where x is the number of minutes after 40.
Okay, so I subtracted 650, so I get 12.
Yeah, but wait. We gotta move on to the next one because I'm gonna run out of time.
Okay.
I trust that you can solve it. That's the secret. I trust you can solve it. The key is to set it up. I mean, I'm more than welcome to help you with 3, but we're gonna run out of time if I. Yeah. Okay. The length of the side of a square is 10 centimeters. Fine. So that means all the sides are the same, with a measurement of error of at least 1 centimeter.
So I don't know what a measurement error is.
A measurement error is plus or minus. So, with a measurement error, so in other words, the area is an inequality, right? Because the area can be bigger, is going to be, first of all, let's say there was no error at all, right? So the area of the square is 100 centimeters, right?
Right.
So the area of the square is going to be, x is going to be less than some bigger number than 100 and greater than some smaller number than 100. because the length of the side of the square is 10 plus or minus 1. See?
So I don't really understand.
So, okay, the length of the square is 10 plus or minus 1. So the biggest it could be is if the error is on both sides. So the biggest it could be is 11, and the smallest it could be is 9. Right?
Okay.
The biggest it can be is if the error occurs as the maximum, which means it's 11 by 11. It's 11, right? Because, okay, if you're measuring it at 10, it's basically telling you it's not 10. It's not 10. It's somewhere between 9 and 11.
So what do I do?
Well, if it's 11, what would be the area of a square if all the sides are 11? Okay, what would be the area of the square if all the sides are 9?
81.
So the area is between those two numbers. So the area is between 121 and 81.
That's it?
Yeah, I think so. Yeah.
Okay, so now that we have a couple more minutes, can we go back to 3?
Yeah, we have 3 minutes. So,
Okay.
so it's 1.
So if it's 1850 is less than or equal to 650 plus 10x, you subtract 650, you get 12 is less than or equal to 10x. I
That's
divide it by 10. I got 6 over 5 is less than or equal to x. And then 6 over 5 plus 40 is less than or equal to
No. That just says that x has to be greater than 6/5.
Yeah, or equal to.
Right. Yeah, which is 1 1/5. X is greater than 1 1/5.
It can't be equal to because it has to end up being.
Right. Yeah. So x is greater than 1 1/5. So that means you have to add. Then you have to add. No, then you have to add 40 to it. So it's 41 1/5. Something's wrong. 12 plus 10x. Something. The numbers just don't make sense, right? But I guess 1850 minus 650. We're talking about just 1 minute. It just doesn't make sense. Wait, something just doesn't make sense. If it's 1 minute. Oh, the 10 is a 0.10. It's not 10, it's 0.10. It's 0.1. It makes no sense to divide. You have to divide by 0.1, not 10, because it's 10 cents. Yeah, you see, or just work in pennies. Work in pennies. It's 1,850 less than 650 plus 10x. That's the way to do it.
Wait, there's 10 no.
What?
There's still 10x?
You work in pennies. You got the units wrong. You got to work in pennies. It's 1,850 pennies is less than 650 pennies plus 10x. X's has to be in the numbers. You have to work in pennies, not dollars.
So it all has to be the same.
Yeah, right, exactly. You have, or divide by, instead of dividing by 10, you got to divide by 0.10.
Wait, but I thought now we're working with.
Yeah, no, it depends. Okay, do you want to work in pennies or dollars? If you want to work in pennies, then it's 1,850 is less than 650 plus 10x.
And then you just add 40.
You get the answer, and then you add 40, and that's the answer.
So 160 is less than x.
What is 1850? 1850 minus 650 is what? 1,200? 1,200 divided by 10 is 120. Yeah, so the answer is 160.
Okay.
Right?
Yeah. Okay.
Yep, that's how you do it. Yeah, because with word problems, you got to use common sense. It didn't make any sense for the number of minutes to be only 1 minute above 40. It made absolutely no sense.
Right.
Right? So you got to, when you do word problems, you always have to ask yourself yeah. Anyway, the kid is a second late, so now we can have pleasantries. So, how's your summer?
It was good.
Great.
Yeah, and we went to Greece as a family. It was cool.
Wow, very nice. All right. Well,
I was
oh, good. Yeah, it was restful. It was pretty restful. Much too short, but restful. You know, you can't do anything with the 10 weeks. It's 10 weeks, no matter what you do.
yeah.
Yeah. So, okay. So I'm glad you called.